Hi, grade 6. This is lesson 1-8, and it's page 40, numbers 5 through 41, the odds. This assignment is about the metric system, a system we don't use that often here in America. We do use it for some things. Scientists use it quite regularly and are very capable of using it. But most of us don't use it very often unless we grab a bottle of pop out of the grocery store. Sometimes pop comes in a 2-liter size, and that's the metric system. For some reason, we don't put pop into a 2-quart size. It's about the same amount, not exactly, but for some reason with pop bottles we go with 2-liter size. There are other places in which we use the metric system here in America. Automotive mechanics very often are going to use metric sized wrenches, like a 7-millimeter wrench instead of a 3/8 inch wrench. So there are some places we use this. We're on page 38 and 39 to start with. One of the most important parts of this lesson is that you need to be able to work with the table that's on the bottom of page 39. Bottom of page 39. It's talking there about different equivalent ratios, different equivalent metric units. For example, the very first one says 1 kilometer, 1 km. 1 kilometer equals 1,000 meters. And we can use all of these relationships that are found on here to solve particular math problems that we're going to have to be facing today. So, how do we get started on this? Well, there's a couple ways to do them, but here's the way I like to do these kinds of problems. Let's say that I had 4.5 meter sticks, and I wanted to know how many centimeters that is. I want to know how many centimeters that is. Well, a meter stick is about yay long, and 1 meter stick has 100 centimeters. So, if you look at that purple table on the bottom of the page and you look for a relationship of meters compared to centimeters, you'll notice that there is a spot where it says that 1 meter equals exactly 100 centimeters. It's on the left-hand side, and it's the second one down from the top in the purple table on the bottom of 39. Now notice something here. I did not write it centimeters equaling meters. I did not do this. I lined up meters with meters and centimeters with centimeters. And now I'm going to study this. If it's true that 1 meter equals 100 centimeters, can I use this relationship to solve this problem? And I can. Notice that to get from here to here, I end up having to multiply by 100. 1 meter is 100 centimeters. 1 times 100 is 100. Let's use that same relationship here. What's 4.5 times 100? If I work that problem out, I get 0.005, 0.0004, 0.0054. There's 1 decimal place value in the problem, so I start on the right-hand side, I count over 1, and I get an answer of 450.0, or in other words, 450. And that's the correct answer to this problem. 4.5 meter sticks, about this long, 4.5 meter sticks, that's the same thing as 450 centimeters. So what did I do? I used the known relationship on that table to help me solve the unknown relationship right here. Let's try another one. What if I have 28 centimeters and I want to turn that into an amount of millimeters? 28 centimeters. How many how many millimeters is that? Well, look at the purple table. Find a relationship between centimeters and millimeters. I found one. It says that 1 centimeters, notice I'm putting centimeters over centimeters and millimeters over millimeters, equals 10 millimeters. So what's going on here? How are we getting from here to here? I'm multiplying by 10, right? Multiplying by 10. And what I do down here, I'm going to borrow that and use it in this relationship. I'm going to multiply by 10, and the answer is 280. So 28 centimeters is 280 millimeters. Let's try it again. What if I have 438 centimeters, and I want to turn that into an amount of, whoops, I didn't write centimeters. And I want to turn that into an amount of meters. How many meters is that? Again, I look for the relationship. And the relationship says 1 meter equals 100 centimeters. 1 meter equals 100 centimeters. But if I write it that way, I'm not going to line up centimeters with centimeters and meters and meters. So watch how I write it. I'm going to switch places with it. Instead of 1 meter equals 100 centimeters, I write 100 centimeters equals 1 meter. Because I want to line up centimeters with centimeters and meters with meters. And now let's look at what's going on here. What are we doing to get from here to here? We're not multiplying this time. We're not multiplying. Instead, we are dividing by 100. And what we do to this, we're going to have to do up here as well. We're going to have to divide by 100. Well, let's see what we get. 438 divided by 100. What does that equal? Well, there's a 4 in that. Uh-oh. What are we going to do now? Well, let's put a decimal point here. Put a 0, bring it down. This goes into that 3 times, right? Got 80 left over. Let's bring down another 0. 100 goes into 800 8 times, and we're done. So 438 centimeters is really also the same thing as 4.38 meters. Again, I'm using the known relationship to solve for the unknown relationship. I know this is true because the book says so, and I use it to solve this. Okay, let's try another one. What about 72 grams? And what if I want to change it into an amount of milligrams? Look for the relationship on the bottom of 39. Grams and milligrams. What's the relationship? Well, if you look carefully, it says that 1 gram equals 1,000 milligrams. Where is that? 1 gram, 1,000 milligrams. It's on the left side, about the 5th one down, I guess, right? So what's going on here? We're multiplying by 1,000 to work our way from here to here. So we're going to use that same relationship up here. We're going to multiply by 1,000. And 72 times 1,000 is 72,000. So that's our answer for that one, 72,000. We're using the known relationship we found at the bottom of 39 to solve for the unknown relationship. Let's try another one. What if I have 202 grams, and I want to change that into an amount of kilograms? All right, look for the relationship on the chart on page 39. I see that 1 kilogram is 1,000 grams. But I don't want to write it like this, because if I write it like this, I don't have grams under grams and kilograms under kilograms. So I'm going to flip these around, and I'm going to write it like this. 1,000 grams equals 1 kilogram. Now, study the relationship. What's going on here? We're dividing by 1,000 this time, right? Dividing by 1,000. So we've got to do the same thing here. We're going to take that 202 and we're going to divide it by 1,000. Well, does 1,000 go into 202? Nope. It goes into it 0 times. But we can put a decimal point here, put a 0 here. Oops, excuse me. Bad subtraction. And we can bring that 0 down, right? We can also bring this decimal point straight up. How many times does 1,000 go into this? Twice. Let's Let's bring down another 0. How many times does 1,000 go into this? 0 times. Let's bring down another 0. How many times does 1,000 go into this? 2 times. And we're done. We finally got down to a remainder of 0. And there's our answer. Our answer is 0.202 kilograms. 0.202 kilograms in this particular case. We use the known relationship to solve for the unknown one. Okay, let's try another one. How about 2 liters equals how many milliliters? 2 liters equals how many milliliters? Look for the relationship. It tells us in the book that 1 liter equals 1,000 milliliters. This one's pretty easy. What we're doing here is multiplying by 1,000 to get from here over to here. So we're going to do the same thing here. Take this times 1,000, and we get an answer of 2,000 milliliters. How about another one? What if I have 2.4 kiloliters, and I want to know how many liters that is? Again, we look for the relationship down below. It tells us that 1 kiloliter, boy, that's interesting, I don't know where that came from, equals 1,000 liters. Kiloliters under kiloliters, liters under liters. What's going on here? We're multiplying by 1,000, multiplying by 1,000 as we work across here. So we're going to do the same thing at the top. We're going to multiply by 1,000. And now we got to take 1,000 times 2.4. 0, 0, 0, 4. Second row, automatic 0. 0, 0, 0, 2. I get 0, 0, 0, 4, 2. There is 1 decimal place value in this problem, so we're going to start on the right side and move our decimal point over 1 spot. And when we do that, we get an answer of 2,400 liters. 2,400 liters. So 2.4 kiloliters is the same thing as 2,400 liters. How are we doing so far? How are we doing? Well, let's try this one. How about 23.5 grams? And we want to know how many milligrams that is. How many milligrams is that? Well, the book says in that chart that 1 gram equals 1,000 milligrams. What's going on here? We're multiplying by 1,000 to work from grams to milligrams. So we do the same thing up here. We're going to multiply by 1,000. And what does that equal? Well, I'm going to have to do some math again. Uh-oh, going to need an automatic 0 there, aren't we? 1, 2, 3, 3. In the third row, I'm going to need 2 automatic zeros. 1, 2, 3, 2. And our final answer ends up being this. But we've got 1 decimal place value in the original problem, so we're going to move that decimal point over 1 spot, and we're going to get this answer, 23,500. 23,500 milligrams. How about this one? 9,014 grams, and we want to change that into an amount of kilograms. The book says that 1,000 grams equals 1 kilogram. It says so on the bottom of 39 on the left-hand side there of that chart. This is a situation where we're dividing by 1,000 to work our way over from grams to kilograms. So we're going to do the same thing. We're going to divide by 1,000. So what does this number, 9,014, divided by 1,000 equal? This goes into this 9 times. We're going to have to put a decimal point there and bring down a 0 and bring that decimal point straight up. This goes into this 0 times. Let's bring down another 0. It goes into this 1 time. And it goes into this 4 times. So there's our final answer, 9.014. Have you noticed that all of these answers we're giving are basically the same as the number we started off with? It's just that we're either moving the decimal point to the right a certain amount of places, or we're moving the decimal point to the left a certain amount of places. In this case, because we were dividing by 1,000, the decimal point was here, and we moved it 3 places over, and it became 9.014. Sometimes the decimal points get moved to the left, sometimes it's getting moved to the right. Okay, so those are some example problems for this assignment. Your assignment is page 40, numbers 5 through 41. And yes, you may use calculators today for some of this assignment for figuring out the calculations. Okay, have a good day.